let's do it. So last time we talked about AJAX. I was only able to briefly introduce it, and we didn't really get to talk about it in depth. So I want to finish up AJAX, show some examples, and we'll talk about polling briefly. I don't have a whole lot to say about polling, so we might get caught up today. Then Friday will be mostly review, homework help. I might have one or two small topics that I want to throw up there and talk about quickly. But if you have questions about, specifically about homework 4, that's what you're all going through. If we can turn that into homework help, I think that would be most beneficial to the class. So if you have specific questions, bring them on Friday, and I can give live examples, go more in depth into certain topics, just do mostly catch up, review, reinforcing the content. All right, so AJAX. We talked about AJAX, how we can make requests after the page loads and make those requests asynchronously, which means they happen in the background while the user is doing other things and while the page is doing other things. We can have concurrent code running. But why do we want to do this? And we quickly saw 2 reasons why. After page loads, we see this all the time on the internet. It's very, very common architecture now. You make a request, you get the HTML, which is just a skeleton of the page, and that loads very quickly. You can get your page load in a fraction of a second, and then slowly these AJAX calls are made, and then the rest of the content comes in and starts populating on the page after the page load. So that you've seen that. You may have wondered what was happening there. This is what's going on. It may have some more sophisticated architecture, but this is the underlying concept. Page loads quickly, content is served later on with some asynchronous requests. We also saw just an improved UX in general. You don't have to have those page loads, so we don't have to have refreshes every time content is updated. So thinking of a chat app that we'll see, we'll take a look at the code for my chat app using AJAX. That would be pretty prohibitive if you had to reload the page every single time you wanted to get new chat messages. At best, the screen's going to be flickering as it constantly updates to check for new messages. At worst, you have to manually refresh to see the new messages, which really defeats the purpose of that app or anything to that effect. Anything in that theme of a chat app, any real-time, I don't want to say real-time yet, but any live, what's the distinction between those though? But any interactions between users where you want to constantly be communicating back and forth. The reason I don't want to say real-time is we're not quite real-time yet. That's what we're going to use WebSockets for, to get our full real-time interactions. For example, I don't want to get too sidetracked, but since I brought that up, let me briefly mention it. With AJAX calls, we're going to make requests after the page loads and get new content, but think about if you're, say, playing a game where you really need that real-time, as fast as possible updates. How are you going to use AJAX calls to do that? You'd have to be making calls multiple times a second. It'd be a little bit prohibitive. You want those instant as possible interactions if we want to do something like that, something like live gaming or anything that requires instant feedback. We're talking about chat app now because if there's a 1-second delay on a chat app, which we'll see later in the content when we talk about polling, if there's a 1-second delay there, it's not that big of a deal. But if you have an application where a 1-second delay is prohibitive, it's where we're going to pull in WebSockets. All right, what we didn't get to last time, let's talk about how we're going to encode these AJAX requests. And the first option, which these next few things that we talk about, the encoding and when to render is another topic we'll talk about in a second. There's a lot of choices here in your design. I'll talk about what each choice is, what the pros and cons are. For the homework assignments and for your project, it's up to you to decide which route you want to take. But I'll throw out there what options you have available to you, then you can pick which ones to use. So the encoding for this, we can do what we've been doing with forms, multi-part form data. If you already have this code written, or you will for homework 4, so it's kind of a simple option. If you just get the data like this, throw it in your code that you've already written, you already have it parsed, and then you can use it. So if you want to keep using that code, you wrote some rock solid code, you're happy with it, it's working for you, you can get your AJAX request to use the same exact encoding. The setup for the form is a little different because we don't want the form to make an HTTP, we do want the form to make an HTTP, no, we don't. I'm going back to my first one. We don't want the form to make an HTTP request. We want our JavaScript to make an HTTP AJAX request. So if you recall from forms, we said whenever we submit a form, it's going to trigger a page reload. And that's specifically what we're avoiding with AJAX. So what we do is instead of having our either post or get and the path, we don't specify that information here. Instead, we're going to tie into the onSubmit event. So whenever we get the submit event for this form, we're going to run this JavaScript code. I have a method, function. I have a function named sendMessageWithForm. We'll look at that code. I don't believe I put it in the slides. I should remember that. But we're going to look at it when we go to my code. We're going to see that. But trust me, this is a function that's going to make the AJAX request. And then, very importantly, we have this return false statement as well. This return false is going to prevent the form from making an HTTP request. So if we don't specify the path or the request type, so it'll have default options. I would assume it'd be get to the root path. I'm just guessing there. Why would you not specify your things? But it will make onSubmit, a form will trigger an HTTP request and will reload the page with the response from that request, which is not the behavior we want for this particular, for our applications now. Return false is a separate statement separated by semicolons. We have two statements here. Return false is going to prevent that page reload. If you forget that return false, the page is going to be all kinds of broken. You need that return false in there. With this return false, even if you specified your path and your request type, the return false is going to block that request. So the form is not making a request. We're preventing the form from making a request, but we are making a request through our JavaScript by making an AJAX request. Oh, I did. Okay. So let's take a look at that function earlier than I expected. All right, so now that we have that call to our JavaScript, we got to get the information from the form, put that in a post request, and then make that post request to our server. So we have our AJAX set up. We're going to have our XML HTTP request. I'm cutting out some of this just so I can fit everything on the slide, but that's where we would check the ready state and check the response code, and then handle the response accordingly. I just removed that to fit on the slide. But the new stuff that we're looking at here, we can pull the data from the form by taking the HTML element of type form, creating a new form data object, and then just sending that form data object directly in our post request as the body. Since we set the encoding type to multipart, that's going to have the same exact format as if we submitted the form through a post multipart request to a specific path and then just reload the page with the response. We have that same exact format, except now it's going to be in an AJAX request. So if you want to reuse all that parsing code, and when you're writing these AJAX forms for homework 5, pull the form data, send that form data in the body of the request. You don't have to change your server-side logic. Call that same method you have to parse all that multi-part information, find the boundaries, and check all that stuff, and get that data. Oh, one thing, I'm glad I remember this, with the boundaries, one thing I neglected to mention in lecture, the beginning and end of the boundary, the boundary data, and I believe the beginning of every boundary itself is going to have 2 dashes in there. If you have these extra dashes in your code that are tripping things up, make sure you're looking for those extra 2 dashes. I believe it's leading on every single boundary, and also 2 dashes at the end of all of the data in the post request. So if you're getting tripped up on that, if you're just splitting on the boundary, make sure you're checking what actual data you're seeing when you do the splits, because you're going to have those extra dashes in there. So just a heads up if you're having headaches on that homework 4, that's one thing to look for when you're parsing these multi-part forms. All right, so this code gets us the form data, pull the form element by ID, that was the form itself. And then any inputs that I have, I just have one input here, but any inputs you have, if it's file uploads, it's whatever, that's going to give us that information in that same format as we saw before. Form data, pull the element, create a form data object, no extra processing on our end, the form's going to take care of it. Client side is going to take care of all that work. One other option, there are lots of options, it's however you can get your data in the format, whatever format you want. But one other option I'll throw out there is to not use a form and kind of build our own custom forms out of just HTML, just the elements that we have. So here, I no longer have a form. I can still have my inputs, and I can have these however I want, organized however I want. I don't have to have them in a form or just however I want to design it. And then instead of an input that's going to be of type submit, I'm just going to create a regular old button. A button that's not connected to any form. It's just out there on its own, like we did with homework 1, where you created a button tied into the onClick event. Then when you click that button, there's some JavaScript code that's being executed. So here, I just have a button, call some JavaScript. There's no submit input, there's no form, so I don't have to worry about accidentally triggering an HTTP request in a page load. I don't have to worry about that return false. So there's some things we don't have to think about anymore, but we do lose a lot of functionality. I'm going to call this send message function. We do lose some functionality because now we don't have a form to just say, hey form, give me all your data and send it in the post request. We can't do that anymore because that form doesn't exist. We can have the form do our multi-part encoding. We can have our form do the URL encoding if that's what we wanted to do. We can't do that anymore because we lost all that structure. But we can go to each input individually. I just have one for this example. But go to each input individually, get that element out of the DOM, get its value, and then work with those values directly. So we can take this value. I put it in JSON for this example. This one's simple enough. You'll see when I jump to the code, I actually did this without JSON. I just sent the message directly as the body of the request. But if we had more than one, value here, I really want to throw that in a JSON object. That's the approach that I would take. It's fairly standard to just to use JSON when working over the internet. So I'm throwing this in a JSON object, stringifying that JSON, and then sending that as the body of this request. So I'm not parsing all that multi-part form data. I'm just parsing a JSON string. If you're using, for those of you using Python, which I think is most of the class, I believe. If you're using Python, you get those bytes, you decode it to that JSON string, and you say JSON.loadS. And that's going to turn it would turn this into a Python dictionary, and you can work with it in your Python data structures. So JSON has nice support in Python, JavaScript, several other languages. Java, Scala, not as much. You got to pull in a library and do a little extra work because those languages are strongly typed. C++, but I don't think anybody's using that anymore. I don't believe I saw any of those on the assignments. In Go, I'm not too familiar with Go's JSON, but if Go does have a JSON library, and also Java, Scala, you can. Let me back there. I did say that last time. You can use JSON libraries, right? Okay. Yeah. So you can pull in the JSON libraries for those languages, whatever standard JSON library there is for Go, Java, Scala, anything you have for that. Yeah, I did say it because so many of you are using Python, you have that library readily available. It's just part of the language, and it's not part of the course, so I have no problem with you pulling that in. Approving something like that would be like me having to approve loops or something. Like it's just part of how you use that. Like I didn't approve any string parsing stuff either. It's just assumed that you can use all that because it's not part of the course. I'll say the same thing with JSON, except for those languages where it's not built into the language. You can pull something in You can pull in a library to do that JSON parsing, if this is the approach you want to take to do JSON. So like I mentioned, there's a lot of design choices in this class. At the 300 level, I am assuming that you can do, and also that you want to do, more design decisions. How do I want my web server to be structured? And then choose whatever you're most comfortable with, the approach you think is best. But I want to give the options out there. And also part of that is, I have no idea what you're going to see out there in industry when you graduate. I'll expose you to the options so you're at least aware of each one, and you'll get hands-on practice with whatever one you do choose. But whatever you see out there, every team, every company, every organization, they're all going to have their own choices. There's a lot of choices to be made. All right, so we also have another question about rendering content. So far, we've seen HTML templates and rendered content that way. I want to throw out one other option and also talk about the pros and cons between these options. So how are we going to do this? One option, HTML templates, as we've seen. With this, we're rendering the content server side and serving HTML. The client doesn't see the rendering happen. It's all behind the scenes, and the client just gets HTML. When they requested a full page, they just got all the HTML. They didn't know it was generated from a template or not. When they're making AJAX requests, we can do the same thing and just have kind of smaller templates. If we want to generate all of the chat history, for example, have the server pull up all the chat history, have a template that doesn't have like the HTML head, the body, and all those tags, but just the HTML for that text, for the chat history. Render that client server side, and then send that HTML to the client, and then the client can pull up some element where that chat history is supposed to go, and then set the inner HTML to whatever the response was. So we can take this same approach. This has advantages and disadvantages, as I said. One big question with either of these choices is, whose CPU are we using? And this is a tough question. Like when you're designing an app, whose CPU should we use? It's a tough question to answer. There's no clear right answer. You can use the server CPU to do all the rendering, but that extra load on your server is going to be more costly for you to run the app. So it's tempting to say, no, we're going to make our users use their CPU, but then you have slower page loads, because now they have to run some JavaScript to generate this content. They're, especially on slower machines, if they're on a Chromebook, well, that's going to take longer for the page to load than if you rendered that on a powerful server, render it in a fraction of the time, and then send the HTML. You're also just generally using up their CPU, using up their battery life, using their resources, can decrease, besides just page loads, decrease the user experience. So all things to consider when we're making these choices. And also, what if you want to make a mobile app? This is restrictive if you know you want to expand into the mobile space later on with your app, and you want to use that same server. This is very difficult to do if you're using HTML templates that are rendered server side. So you want to go to a mobile app, you want to write native, specifically native mobile apps. You want to write native Android, native iOS apps. You can't just give it some HTML and have it just run that. You got to write in those languages. You got to pull out Swift or Java or whatever you're using for your app. So you can't use this server as it's designed if you're using HTML templates. Unless there are ways where you can just take a website, a web app, and just convert it into a mobile app, or a desktop app for that matter. But those tend to be pretty clunky, pretty slow, pretty wasteful. It's an option, but you're not going to have the performance that you might want from your mobile apps. So a lot of the design decisions to consider. For this class, for your homeworks, it's probably going to be whatever's easiest for you. But these are the decisions you got to make when they're building, say, Netflix. They got to make decisions here. And of course, Netflix, they're deploying on every platform you can imagine, so they're not using HTML templates. I would suspect not anyway. I haven't dug into that one to check firsthand, but I would suspect they're not using HTML templates. All right, so let's talk about an alternative. Host the raw data on your server, and then the client renders that content and converts it into HTML that they can view, that the human can view in their browser. So now, instead of hosting a web app necessarily, instead of hosting HTML for our data anywhere, we're going to host HTML at some point to get the structure of that page for the web app part of our app. But instead of hosting the whole web app, we're going to host an API. So after the page loads, all those AJAX interactions are going to be to an API that serves up raw data, commonly in JSON format. We're going to send JSON on all these AJAX requests. The client is going to get the raw data and use up their CPU to render it into HTML, to make it into a content that's consumable for humans to be able to be rendered on the web page. So now we're using their CPU. We can have increased load times, especially on slower hardware, and have all those disadvantages on the client side. If that's not a concern, and if maybe it's a small amount of data and a small amount of processing, maybe this isn't a concern. But it can be a concern if there's a lot of data. So now we want to go to a mobile app. We want to build that native mobile app for maybe 10 different platforms, not necessarily just mobile, but if we want to expand into different platforms, we want an Xbox app, we want a Roku app, and we want to go into all these other platforms, we don't want to rewrite our entire server every single time. If we're hosting an API that's serving JSON strings for all our functionality, now it's a lot easier to move into each one of those spaces. You build a new front end in each one of those spaces and tell it to make those HTTP calls to your server, get that JSON data, which is going to work on any of those platforms, it's just a string, and then render that content for that specific app. So now you're using one server, you're writing one server that's hosting all your data and all your functionality, but you can deploy it to multiple platforms. And this is what most major sites are going to do. The Netflix example, they're going to have the API, at least for their content. Like there's going to be some line where they make the native code for the front end. But at some point, they're going to start hitting this API, at least to serve the content itself, the actual movies that are going to be streamed. That's all one server that all these different apps on all these different platforms, they're going to make requests to that server, get that content, and you don't have to have a separate server for every single platform that you want to deploy to. So there's nothing in our, well, there is some, but in the servers we're building, there's not a lot that says this is a web app, except when we're serving the HTML, the CSS, and the JavaScript. If we write a desktop app that doesn't need that HTML and the CSS, we build our visuals in that desktop, with the desktop app, and then use something other than JavaScript to make the AJAX calls. We use the same server. There's nothing inherently web about, there's nothing inherently web about our servers. It is inherently internet, it is inherently HTTP, but it's not inherently web, as in loading HTML in the browser. We can use all the same stuff. You can write a Python script that makes an HTTP request. You could build that code into Python GUI and build a whole desktop app using our same servers. We just wouldn't request the HTML, CSS, and JavaScript, but we would request make all the AJAX requests if we're hosting JSON strings or data in some other raw format. That's something we can't do if we're rendering HTML templates and then sending those templates. We are locking ourselves into being a web app if we're rendering all of our data, including our AJAX calls, using HTML templates. Yes?
You said we're getting allowed to use libraries to parse the JSON objects.
Yeah, and wrote JSON.
Okay.
I was listening to you. Any questions on that? I kind of talked about that more than I thought, but it's an important point to know about these things. Yeah.
As far as web apps go, do most
major companies do like some combination of those, because like a lot of the initial page loads still look and function before all the AJAX requests come in. So like, is it like a combination usually of like balancing what is best to send post with AJAX versus rendering with the CPU?
It's always dangerous to speak in general, so take this with a grain of salt. But yeah, most major apps, they're going to have the structure loading immediately. So for a web app, you're going to make that request, get that HTML, the CSS, and the JavaScript right away, and then make AJAX calls for the rest of the content. The same is true for other apps. Like if you have a mobile app, what you effectively have done is download the front end for that app when you went to the App Store or the Play Store. You downloaded the front end, which would be the equivalent of the HTTP, the CSS, and the JavaScript. So when you open your app, that front end is already there. You have an immediate, your app opens and it's there right away. And then it's going to start making the calls to the server to get the specific content. If you're opening a social media app, like your app loads immediately, and then the content starts coming in. It's going to be the same concept, but different in each case. If you go to Netflix, like it takes a while to load all that stuff, what we saw earlier. Netflix itself loads right away, but then it takes a while to get all the movies, especially when they're serving your specific recommendations. That's a database query, that's an AI algorithm. It's a bit of stuff that they have to do, so that takes a little bit to populate.
So the client-side rendering consists of just a series of JSON inquiry calls?
Yeah, the client-side rendering, yeah, typically.
Series of AJAX requests.
Yeah, typically. I mean, this is one architecture. Obviously, not all websites do this, but this is a common approach, is the AJAX. It's AJAX to get a lot of content. Not necessarily JSON either. That is the most common approach, but AJAX calls to get the content after the page loads. It's pretty common. Especially when you have a page where the content is swapping in and out as you're using the page, or if you have anything with an infinite scroll, that infinite scroll is, as you scroll down, making more AJAX calls to get more content. So as you're navigating the page, you're making more and more AJAX calls. Am I at the, I think I'm at the, oh, no, I'm not. I got an important topic to talk about. So say if I'm at the end of my slides, I could do a few demos, but maybe that's what Friday's for. If nobody has specific questions about the homework, maybe we'll just run around on the internet and see these things in action. It might be a good use of our Friday to get a more concrete how real web apps do this. I want to try to get that in the course as much as I can. Friday might be the best time, one of the best times for that. I'll go to a site with an infinite scroll. And anybody, if you have sites that you want to see how they work, I would love to take recommendations. It's always, because I want to do that more often, and when I do sit down to set that up for a lecture, I usually blank out for like 5 to 10 minutes sometimes, like what site do I want to even explore? But if there's something that y'all are using that I'm not, I don't, Snapchat's a thing, but I don't use it. If all of you are interested in something like that, and go check that out, see how it works, and then prepare some lecture content. I don't know if in this group, I don't know if you're into Snapchat or not. So if you are, I don't know, make a Piazza post, I guess, make a poll, or not, and then I'll just do whatever. I'll just come up with some sites. All right, so rendering content, it's up to you. This is another design decision. If you don't have great multi-part encoding code by the end of homework 4, you just barely limped through and got that going. Maybe you don't want to use that for homework 5. Maybe you want to start fresh with JSON. If you didn't have your templating great for the images, maybe you hard-coded for that specific case and didn't even use an HTML template. Well, you probably don't want to render with HTML templates. It might be more work than just serving JSON and then rendering it client-side. So all decisions, whatever's best for your specific situation. You got some choices here, but you know the goal that has to be accomplished. Page loads, user has some interaction that makes an AJAX request. You get a response, and all the other users, active users, have to get that new content and render it on the page. That's what we want to build. So the chat app, as an example. That's what we need to build. However you get there using these technologies, that's up to you. All right, we got to talk about something very scary. At this point, we got to the level where we're handling user-submitted content and sending that content to other users. Once we hit this point, there's some very scary stuff we got to work with that we got to be aware of. Is what if these users are sending malicious content? What if they have ill intent and they want to harm our other users by doing whatever they want to do? So we have our chat app built, and somebody submits this. They have some function with some very malicious JavaScript. Now I'm sending that to everybody else, and that JavaScript that an attacker submitted to the chat is now being ran on everybody's machine, anybody who uses this site. This is a scary thing that we got to handle. This HTML injection, JavaScript injection, or cross-site scripting, as it's commonly referred to, or XSS, cross-site scripting. This is something we have to be worried about. Yeah.
Does this at all relate to like online stores? Because I always wonder how that works and how it's safe versus compromised, like making it personally.
Yes. This is definitely part of it. You don't want your online store to have this vulnerability, or any website, really. This vulnerability is very scary. But usually if you have this vulnerability, somebody's going to exploit it almost immediately, and you're going to know. So this one's hard to have. An online store, we got to talk about encryption, which is after spring break. Talk about encryption and maintaining our privacy. Right now, so far, all we've done is HTTPS. Everything we're doing is HTTPS, which means everybody can see what we're doing on the internet. And we'll.
S doesn't mean secure.
S means secure, but we're not using that in the homeworks. You haven't built any encryption into your servers yet.
Sorry. Tom Scott did a great video on the self-retweeting tweet, which uses this technique. Is it okay to put that on the other side? Or?
Yeah. Yeah. So what is this, and how do we protect against it? Protecting against it isn't overly difficult, but it's something that if you forget to do, some user is going to destroy your site really quick. And for homework 5, I think I only put it in the last bullet point, is you can't be vulnerable to this attack, or it's going to be a 0 for that objective. For objective 4, when you're rendering the content, when you're sending the content to other users, if you're sending your users potentially malicious content, it's going to be a 0 for that objective. And whenever it is a security concern, which I think future iterations of this course, future semesters, is going to make it more severe. If you have any security concerns in your apps, this is critically important. You're going to write web apps. If you have a vulnerability, you're putting a lot of people, potentially all your users, at risk. It's a big deal. I got to drive that home. Right now, it's only a 0 on one objective, but we need to be aware of the security issues when we're hosting these web apps. So this one, not too hard to prevent against. At least the first line of defense is pretty simple. Ampersand, less than, greater than. Escape these characters with their HTML escape tags. From way back on week 1, we can escape these characters using using their names, or we can use their Unicode bytes in this ampersand notation. But some way you got to get rid of these. So if you have user-generated, user-submitted content, replace each one of these with their escape sequences, and that's it. I mean, try to write HTML without those 3 characters. It's not going to go very well. Not really going to be able to do it. So now this is just interpreted as text. It's not interpreted as HTML anymore. All right, let's see some of this in action. We got a decent amount of stuff to catch up on in the server. So I set up those 2 forms, well, the one form and the one kind of makeshift form that we saw in the slides, to be able to make these AJAX requests. What I didn't really show is the server side, but the server side isn't overly complicated. Let me clarify that once I find it. So So if I get a post request using my makeshift form, or if I get a post request using my other form, parsing this is the same stuff as you've done before. You get a post request, here's the format of the body, you got to read the content link. This is all stuff we've done before, so there's no new content to talk about. The server does not care that that's an AJAX request. It's just another HTTP request. The server doesn't care that that request was made in AJAX fashion. It just doesn't care. In our design, we can care just by, what do we send as a response? I'm just going to send a message that says, hey, I got your chat message. But for my application, for my chat app, I'm not even rendering that to the page. It's just a message for the console, and then I just print it to the console on the front end, just to show you that we did get a response from that. But I'm just going to call my multipart parsing for the form, get a map of all my keys to values. I'm going to get the message out of that, convert it to UTF, call this clean message, which currently just trims the leading and trailing white space, but we will be escaping our HTML. So I'm doing something very unsafe here by not escaping my HTML. And with my makeshift form, I'm doing the same thing, except I'm just cleaning the message. I skipped the JSON part of this and just took that string as plain text. Probably not the best approach, but just for the sake of example here. And then I'm appending this to my chat history. Again, just sending a message back saying, hey, got your message as plain text. And then I have the chat history, which is just a list of strings. So I'm storing all of that information. And this is where, for an advanced app, for a full app, I would be writing those to a database and then doing database queries. Here, for this sake of example again, just store those as a list of strings. And then I have one more path. If somebody sends me a GET request for GET messages, I'm going to take that whole chat history and I'm going to write it in some, I forgot I was showing this in lecture, I should have done this, but just some makeshift JSON formatting. So I'm writing this as a JSON array, but I'm writing it manually, not the best thing that I should have done, and then sending it as JSON. I should have used the library and did that properly. I tell 116 students to not do that. I'm doing it in 312, but let's ignore that for now. Anyway, so I have my forms, I have my JavaScript that we saw in the slides. We don't really need my test. We don't have sockets yet. But send message, same stuff we saw in the slides. A little extra stuff, I'm going to blank out the value of this and focus it. I didn't end up doing that on the form, but I did it here anyway. Because I'm looking at the wrong thing. I'm in the wrong file. I was wondering why I didn't remove all that stuff. Okay, let's get in the right file. So send message, I'm going to go to that input, get the value. I'm going to blank out that form, something I found out real quick the first time I did a live demo and let students in a class play with my chat app. If it doesn't clear, they'll click submit 1,000 times thinking it's not working, and then they got 1,000 messages sent to the server. So I learned that one the hard way. Always clear out that box, and then refocus the box is a nice UX thing. And as long as they didn't submit nothing, I'm going to send this to that send message path as a post request, with the body just being the plain text value here. And then when I get the response back, I'm just going to print it to the screen. I don't have to do anything with it. I don't have to do anything with that response for my purposes. Send message with the form, same idea, except I'm using this form data and using the multi-part encoding. And again, just printing the response to the screen. And then get messages. Remember, I chose the JSON approach. So this is going to get a JSON string representing a JSON array, which is I want to render client side to get this chat. So I'm going to send a GET request to get messages, send that, and then call render messages with whatever I get back, whatever the response is. I'm going to call render messages. I'm going to get an empty div that I have in my index. So I just have a div here that's sole purpose is just for me to be able to add content through JavaScript. I don't want to write any hard-coded content there. I'm going to get that element. I'm going to parse my response. And then I'm going to append all those messages separated by new lines in my chat div, so I can render all that to the page. I should have done that on the form one too. The focus just puts that element is the one that's currently in focus for the user. So if they type characters, that's where the characters are going to go. Because once they click the button will be in focus, and they can't just quickly type another message. A few UX things. I could have added more UX things here, but I wanted to focus on the AJAX. Another thing, I would like enter to send a message, so you don't have to explicitly click the button. But for the sake of our example here. So I did a few of the UX elements, but not all of them. Also, if you want to think about the front end, I keep forgetting to pitch this. If you want to talk about the front end more, Alan Hunt has a great class, Human-Computer Interactions. Definitely check that one out. This course focuses mostly on the back end and building the functionality and the technical details of that. His course is kind of the other half of this course, the front end, getting the user experience solid, and how, as the name implies, how do people interact with those machines. Highly recommend taking that if you're interested in the front end, if you don't want to be a back end only developer. I don't know off the top of my head. I think it's 450, but I'm just guessing at that point. It's something I don't know off the top of my head. All right, so let's take a look at this app. Let's run the server and see the state of our app at this point. It has its own course number now, though. So it was 410 as a trial version, but it did get a new number. I just don't remember what that was. So here's our new app. I have a chat. Hi. Hello. I can send these. I can see that they sent. And I can see my server going nuts in the background here. Actually, it shouldn't be going nuts. But I get my confirmations. I can check my network tab and see that I am submitting these and getting my response, and then just printing the response to the console. But I can't see any chat. I have this separate button that's linked to, that makes an AJAX request to get messages. That's going to get the messages and render them to the screen. But I do have to explicitly click this button, which is a bit painful. I know why this is going nuts. It's because I have a tab somewhere else with this page open that I forgot to close. But let's do one other thing, just as a proof of concept, to update the chat. And somebody else wants to say something, update chat, update chat. We do have communication between users. There's one issue here, of course. Oops. How come that didn't clear out? Maybe that's, oh, because that's my form. I didn't do that for my form. But I can submit this, and guess what? Every user has that HTML on their page, and they link that button to some JavaScript. They can have script tags just as easy and really attack your users. That button could just have an on-click or just have script tags, raw script tags. You can have some nasty stuff going on in there. So in one of my favorite attacks, the very simple just do an open comment, and then everything after that, unless there are comments in that HTML, everything after that is just gone, because it's all commented out. So we prevent against this by escaping those characters. Now we submit this, and it's just raw text. If we go to our server, we can see that we have those escaped characters. We no longer store ampersands greater than less than's. We're just storing those escaped characters. But when we render those in the browser says, oh yeah, that's the escape character. Let me get the actual Unicode character for that and not interpret it as a less than sign, which can be part of a tag in HTML. So we can prevent against those attacks. At least our first line of defense. And this one, pretty strong. It's pretty hard to get HTML without those 3 characters. So I'll do this. I can finish this up real quick in the slides on Friday, but at least show you the demo of it, of polling. So the app is pretty unusable at this point. We do have to actively say, hey, make an AJAX request for the updated chat. Give me the new content. But what I can do is something like this, use this set interval, which is going to take a function in a number of milliseconds and call that function every that many milliseconds. So in this case, I'm going to call get messages every second. Get messages is that function that makes the AJAX requests and then renders the response on the page. So if I'm calling this every second, refresh to get the new HTML. Now it's faster now. I submit here. We're going to see it on both pages. And we can have that actual chat without the user having to explicitly refresh, reload, or click the update button. Now we have a more functional, I'd say fully functional chat. We can communicate with each other without any really awful UX.